So chapter 4 is factoring and applications. In this chapter, we're going to be looking at all of the factoring techniques that we've looked at in the past, a couple of new ones, and we're also going to use the applications. So now that I've factored it, what can I do with it? Why would we factor equations? What's the purpose behind it? So in this lesson, we're going to review by looking at some of the stuff that we did last year. We factored by removing a common factor, the GCF. We factored difference of squares. We factored trinomials by inspection, and we also factored by grouping. And then we're going to look at, the next lesson we'll look at decomposition. So if we look at class example number 1, it kind of walks us through as to how they want you to factor. Factor by removing the greatest common factor. So I look at both terms, I look at coefficients, and I look at variables. So if I look at 15 and 5, what's the greatest common factor I can divide each of them by? 5x squared. So the x squared would be my variable. So when it comes to the variables, it can never be higher than the lowest exponent. So if the lowest exponent is a 2, the most I can ever pull out is a square. I can't pull out a cube because I don't have enough here to pull out. Because we don't want to end up with a situation where we have negative exponents. We're always trying to keep positive. So if I take out a 5x squared, what am I left with? 3x. What am I left with here? Minus 1. So it doesn't just disappear. Because when I say that I'm taking it out, what operation am I actually using?
Division.
Division. So if I divide 5x squared by 5x squared, I'm left with a 1. In this case, a negative 5x squared divided by 5x squared would leave me with a negative 1. So the term taking it out or removing it means to divide in this case. What's my greatest common factor for B? 4. Even though I can remove a p from the first two terms, because I can't remove it from the last term, I can't take it out. It has to be common to every term in the expression. So if I remove a 4, what would I be left with?
2p minus p squared minus 1.
Good. Now before we start C, a reminder, common factors don't have to be just a monomial. I could have an expression as a common factor. So what's common to my terms in C? The y plus 2. The entire expression is common to both. So I'll remove it from both. And if I remove it from both terms, what would I be left with?
3y minus.
Now take a look at 3y minus 9, and what do you notice? Can divide it by 3. So I can remove a 3 from that, and what would I be left with? So if I remove a 3 from this term, the expression, y minus 3, and I still have my y plus 2. And because everything's being multiplied together, it really doesn't matter the order. I can move the y minus 3 to the front. The 3 itself we usually put at the very front. So monomials we would put in front of these binomial expressions. But if you had put 3 times y plus 2 times y minus 3, that's the same thing as what I have written here. Difference of squares. Square numbers. So square numbers. 4s, 9s, 16s, 25s. Those are squares. X squared. X to the power of 4. B to the power of 6. Those would be squares. Because to take the square root of that would be to divide the exponent by half. Because if you remember from last year, the square root is the same as an exponent of 1/2. So if this becomes x to the power of 4, it's x to the power of 4 to the power of 1/2, which becomes x squared. So it's taking half. And it has to be a difference. So with that in mind, of the 4 examples that are here, which one is not a difference of squares? C. This is not a difference of squares. Even though the 9 and the x squared and the 4 are all square numbers or square terms, I cannot treat this as a difference of squares. So x squared minus 81. Can I take the square root of x squared? Can I take the square root of 81? Okay, what's the square root of x squared? What's the square root of 81? So when I do a difference of squares, I take the square root of the terms, and then in order to get this difference, one of these has to be positive and one has to be negative. And that's so when I do the distributive property, I get x squared, I get a negative 9x and a positive 9x, which together gives me 0, and then I get my negative 81. So if I factored b, what would I get for b?
5a minus 7.
Okay. So what would happen if I factored d?
You got 4t minus 8. And then 4t plus 8.
Would I leave it like that? Just 2? Okay, so if I factor out a 4 from each of them, remember everything is being multiplied together, so if I multiply my 2 4s, I get 16. Now take a look back at the original question. 16t squared minus 64. The common factor, I can take a 16 out of each term. If I divide by 16, I get t squared minus 4, which when I factor as a difference of squares still leads me to the bottom. So there's 2 ways that you could do that. We should always be looking at the original expression to remove a greatest common factor before we start, because that would always simplify things. But even if you didn't, as long as when you got to this step, you recognize that I can factor out something from each of those terms. It's like this one up here. Not leaving it as the 3y minus 9, pulling the 3 out of it. So when you are asked to factor something, it means you are trying to break it down into its simplest forms as far as you can go. Factoring by inspection. Those were the sum and product charts that we did last year. Remember the sum and product charts? So which one is the sum and which one is the product?
Sum the variable.
So which one of these would be the sum?
11.
And the product would be? So I'm looking for 2 numbers that have a sum of 11 and a product of 30.
5 and 6.
5 and 6. So then what would happen when I go to factor this? What would my 2 factors look like? So what do I do with the 5 and the 6 now?
So you go, like you split up the 11a into 5 and 6. Isn't it a squared plus 5a plus 6a?
I could, that's just going to lead me to a lot more steps. If I'm doing this by inspection, once I have the 5 and the 6, it becomes a plus 5 and a plus 6. When do I use inspection? We can use inspection for quite a few trinomials. I'm going to show you how you can use it when I've got numbers in front of this a squared. But if I just have a coefficient of 1 in front of my squared variable, I should be able to use inspection. If I can't use inspection, chances are it can't be factored nicely. And we're going to learn how to factor those ones in this chapter. Okay? So if I look at B, if I did a sum and product chart for B, what's the sum this time? -1, and the product is, so if I need two numbers, I'll multiply to a -30. What can you tell me about the two numbers?
One of them must be negative.
One has to be negative, and then it has a sum of -1. So what I do is I just, if I want to for now, ignore the fact that I have a -30 there. I know that one of them has to be positive and one has to be negative. So when I think of my two numbers that multiply to 30, instead of adding them together like I did here, subtract them. So two numbers that multiply to 30, 30 and 1. If I subtract them, I get 29. That doesn't work. 2 and 15. If I subtract them, I get 13. That doesn't work. 5 and 6. If I go 6 minus 5, I get a +1. If I go 5 minus 6, there's my -1. So if it's 5 and -6, that would be a 5 and a -6 for my two numbers. So when I put this in place, 5 plus 6, or sorry, not 5, B plus 5 and B minus 6. And it doesn't matter if I went B minus 6 times B plus 5. The order of these two terms doesn't matter because I'm multiplying them together. So look at C. The sum has to be -4 and the product has to be 48. So if the sum is negative and the product is positive, what can you tell me about the two numbers? They'd have to be both negative. So when I'm thinking of all of my possible combinations that multiply to 48, I would then add the numbers. So I have 1 and 48. I have 2 and 24. 3 times what? 4 times 12. Can't do 5. Can I do 6?
6 times 7.
And I can't do 7, and then I'm going to be back up to 8, so I'm going to go up this side. So these are all my possible factors. If I start adding them together, do I get a -4 with any of them? Even if these were both negatives. I get a -14, -16, -19, -26, -49. Can I factor this one? Not at this time. So we're not going to say that it's not factorable or that it's impossible. At this point, we just say it's not possible. Because you don't have all the tools yet. Okay, what can I do for D? Take the 3x out first. And then what am I left with? Plus what? So then my sum and product chart would be two numbers that add to -7 and multiply out to 12. So if the sum is negative and the product is positive, we said my two numbers had to be both negative. So what are two numbers that multiply to 12 and add to -7? Good, thank you, Addison. So the 3x will stay out in front, it doesn't disappear, and then I have my two factors. The last method that we're going to review today is factoring by grouping. So if we look at class example number 4, I have 4 terms. I can't take the same thing out of all 4 terms. They don't have anything in common. But if I looked at just these two terms, x squared and -5x, Do they have a common factor?